Uh, it's just like saying what other words that has two meanings are the same. Okay. When we say football and soccer, no? Football and soccer. Uh, in the US they call it soccer, but in Europe they call it football, because football in Europe is different. No? Football in Europe. Okay. When you say football in Europe, in US, it's not soccer. No? So it's the other one. Okay. So in Europe, they call it football, but that's another story. No? So that's just an analogy. No? So uh, floor and slab are the same term. Okay. So what do you mean by slab beam girder? So as I have ako nagigon ganiha, floor system na siya nga ang iyang periphery or iyang perimeter are beams, no? So doon na siya gitawag nga rigid zone wherein nakaatas dito ang slab. Okay? Because slab is usually very thin. It's a thin structure, no? Usually kung wala ka na mga beam, musag na siya, no? Doon na siya sag. So, so the slab will for the slab to not sag excessively, you have to make it a lot thicker, no? But not too thick, because if you have a very thick slab, you have a very heavy structure, and heavy structure requires big beams, big columns, big footings, so which will also affect the cost of the 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 building. Kaya everything is big, no? So you start from thick slab, then because thick slab are heavy relatively to thinner slabs, it requires bigger beams, and bigger beams. Not only that, it also requires bigger columns. Now, because the columns are very big, the building become very heavy. It requires bigger foundation. So, in other words, you have uh, starting from thicker slab, it affects the structure down. No, not only the structure, the cost. This is very important. Okay, cost. So there should be a formula for designing the thickness of the slab. No, so uh, design of slab is similar to design of beam, because slab is usually subjected to bending moment and shear. Okay, bending moment and shear. So kung mauna siya ang force nga nag-control sa slab, then it can be designed similar to a beam. So that is what I am going to discuss this morning. How to do it, no? So first I am going to present. I am going to what we call this. I-document na to ang atong discussion today. So I will present a window, no? So this is it, no? So design, okay, analysis and design of one-way slab. So nga pa din, no? So I will say here, most common type types of floor construction is is the slab beam girder system. Okay? Slab beam girder system. Okay, mo na siya. Now, kanang slab beam girder system, if I'm going to present this one, this is the slab beam girder system. Okay. So in this particular example, kita nimo ang slab beam girder system. Okay. So to laning i-minus to 3 meters, no? 3 meters. And it, yeah, like that is. And then this one, okay, 10 meters. Okay, so as you see here, the flat area here is what we call the floor system or the slab. Now, this slab are relatively thinner, no? Thinner compared to the beam. Okay. Now, this slab can be made stronger if you add some beams around the perimeter. So, if you can see here, the side, all the sides surrounding the slab are beam system. Beam and girder are almost synonymous, no? So we just say slab beam system. Okay, meaning the slab is supported by the beam and the beam is supported by the column. Okay, so that's the hierarchy of the load system. Okay, so what unsa may gakargahon sa slab? Natural ang live load, no? Mga tao nga nagamit, no? Let us say doon na kay mga appliances, doon na kay mga kuan, mga makita nato sa sulod sa building, mga office equipment, mga kitchen equipment, mga sabi na naa sa living area, mga sofa, uh, audio video system. So nakaka na. So they have weight. So and those weight are carried by the slab. So uh, it's a slab that will catch all the live load and other dead weight. Aside from the weight of the slab itself, no? So it's there. So before you are going to design a slab, you should know what are the load that is inside the slab. Okay, so that's the most very important thing to do because the load will be included in the analysis so that you can come up with moment. Okay. So anyway, I'm just I'm just defining what is the slab beam girder system. So uh, it can be pictured as a slab surrounded by beams. No? So here you have a slab and then the beam. Okay. So that's the what. So in plan, I can make it this way. Sa plan lugar unsay tanaw ninyo sa plan. So I can make it like this, no? In plan. So if I am labeling this as a slab, if this one is a slab, okay, that is a slab, okay, slab, okay. And then since this slab is somewhat very pliant or somewhat weak because they are not thick enough, okay, so it should be supported by beams, no? So I'm going to insert another form here on the side to represent the beam. So this one is the beam. Okay, the beam on the side. Okay, let's make that bigger like that. And I will make color one. Okay, that's the beam. Okay, the beam. Okay, that's the beam. Uh-huh. And I'm going to copy that because you supply that same member to the other side. So you have beam on two sides, no? So you have beam on two sides. But the other side, the two sides also, the narrow side, there are two narrow sides and two long sides. It's also supported by beam. So you should insert also another. I will use this one. Okay, I will paste. So I have two, and I will do it like that, and then shorten that. Okay, so you have beam on the other side. So you will do also the same. I will rotate that and I will shorten that. So, mao ni siya ang picture karon, no? So the blue one is the slab, and the other one is the And the orange one is what we call the beam. Okay. Now, doon ay purpose nga ang beam butang sa kilid, no? Not only to support the slab, because there are also other loads that is supported by the beam, no? Na wala na carry sa slab, like the wall. Most wall are found on the exterior side. So, the wall, kada mga wall system, dili na nimo gusto nga nga kagahon ko sa slab, yung mabugatan na pagayo ang slab nimo. So, what you will do is you have to, that's the purpose of uh, putting beams on the side, so that the beam will immediately carry the wall system. It's not the slab. So your slab will be free. It will carry only the intended live load and other appliances. Okay, if there is, and also the weight system. So this is the slab, and then if you are going to ask further, isa may mag-carry sa mga beam. Ang beam ang kan mo yung nagkarga sa slab, pero ang beam isa may nag-carry niya. So kung tanaw mo sa above nga picture, do na tayo stock vertical nga member nga nag-carry sa beam. Ang tawag niya niya columns, no? Reinforced concrete columns in particular. But sometimes they call it post, no? Post. So, another term, post and column, so medyo maglibog ka, pero ayaw na lang libugay mong ulo, they are the same, no? So, but there is proper term, properly they call it columns, no? Columns. So, the design of columns is different, no? So, as in your design of steel, if you, those of you who have already taken design of steel, design of beams and design of columns are of different mechanics, no? So, anyway, so if you are asking what structure will carry the beam, so it's the column. Okay, so we put a column here as to complete our figure. I will put a circular column. Okay, circular column here. So usually columns can be found in four sides, no? But it's not really a general rule, no? But mostly, no, columns are found here. Ideally found here. Okay. So these are the columns. Okay. Now I am going to group all of them. So how to group? So mausa ang figure. Ah, again. Group. Okay, so the group na siya, no? So the group is one. Now I intentionally make the other side longer and the other side narrower, no? Because these are the system. These are the most common, no? Now you can even make that a lot narrow or rectangle. It depends, or you can make it a square. So it depends, no? But the square configuration of plan, uh, it's more of two-way slab. But if it becomes rectangular like this, you can call it one-way slab, no? One-way slab. Okay. So I will call it, if I'm going to put the, kasi tawag ani, dimension. So oh, I will call this one as longer side. Okay, this one is longer side. Longer side, or basically I will just call it long span. Long span. Okay, long span. Okay, that's long span. And the other one, of course, kung doon ay long span, doon sa tayo gitawag na short span. Okay, anong gitawag man siya og short span? Because it is shorter than the other side. So I will call this short span. Okay, short span. Now, kung equal sila, the plan is a square, no, and that is ideal for what we call two-way slab. But if the spans are not equal, you will call that it is ideal for what we call one-way slab system. Okay, so I will continue. No, other one is the slab, one-way slab, one-way slab. Oh, ano na to? One-way slab is designed with respect to short span. So you are going to use the short span, not the long span. Okay, meaning that the reinforcement is here. No, your reinforcement is here. So if reinforcement reinforce reinforcement is aligned aligned along the short span. So that's what we mean by the first paragraph. So if that is so, I can copy this. Ako na lang siyang ano, group yapon. So that means I if that is so, I will put it here. Okay, with steel reinforcement here, no? With steel reinforcement here. Okay, this is the steel reinforcement. Okay, I will color that one. Okay, and then I will format printer. I will format that one. Format. I will make that bigger. Okay. Okay. So these are what we call the reinforcement, no? Reinforcement. So the reinforcement is not only one. Let's say these are what we call the reinforcement. Okay. So so the figure will be complete. We'll put this as long span. Then the other one is this is reinforcement, reinforcement, and this is the short span. Okay. Then I will put an arrow. See, maybe this arrow here. Okay, and then color. Okay, so that is what we mean, no? So if this is the slab, buta nga natin siya ang pangalan ng slab, no? Insert text box. So ano po the six slab? Okay, wala siya slab. Slab. Pang here. No color. Okay. Muna. Okay. So, mauna siya ang slab. So we have long span and short span. It is stated here that one-way slab is designed with respect to short span. Unsa naman rin ang tawag sa reinforcement along the long span? Nagapit ngalan niya ana, no? So tawag na nato siya o ato na siya tawag na test siguro. Okay. Ato butangan o reinforcement niya atong usabon ang iyang line into this. ug ang color niya usabon nato color niya. Ang tawag na ana daghanon na to. Hmm, tawag mo ni in front of this. Ah, yeah. Okay. So, tawag na lang nato ni siya og kuan. Tawag na lang nato siya temperature bars. Ang tawag niya na niya temperature bars. Tem temperature bars. Pink bars na lang, pink bars. Pink bars. Pink bars are also enforcing steel bars, but uh, they are not really designed for moment, but they are designed against crack control. Because why crack control class? Because ini area sa concrete nga walay reinforcement, walay steel is prone to crack. Labi na og doon na siya what we call tensile force diha, no? Prone siya mo crack. Kunya, once mo crack na gali ang concrete, crack na gina siya. Di na gina siya mauli unless you repair it using gamit yung mga epoxy or some tawag ani nga mga chemical, no? Banding chemical. Now, temperature bars are there just to comply the crack crack control requirement. So they're not really designed for strength. Usually spacing na siya, and then usually they composed of small diameter bars. No? So we call it crack control temperature bar. So if I'm going, this is the arrow. I will copy that, copy paste. I will put another. So that's it. No? So temperature bars ang tawag niya na. Okay? Now, kung mukat, so ang beam nga itong makita along the, so there are now two spans. There are now two spans to be considered here. No? You have the long span and short span. But we give importance to the short span. So, kung ato ni siyang buhatan o kitawag nato nga section, okay, insert kong section din eh. Let us say, this is the section. Okay? Section siya. Saka na po. Wallahi. Ulot. Okay. So, mao na siya ang section. Kulang pa dahil siyang line yapon. Ah, ayan. Shit. Okay, color. Ayan. Okay. So, mao na ang section. Okay. Section A. 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 So, we give importance on the short span, along the short span, because Giingon man dinhi nga we designed with respect to short span, and then reinforcing steel is aligned along the short span. So it's the short span that is given importance. So in the elevation or section A. So I do already the section line there. Okay? Meaning, ang umukat ko diha, ang picture nga inyo makita is, this is the one. So, makita ninyo ang slab, nga blue, nga nakita sa ninyo ang beam nga naa sa kilid. Na beam ni sa kilid. So, tanta mo ni siyang beam. Okay, mo na siyang beam. Usually, beam is a rectangle. Tuloy na to orange. Okay? Copy, paste. So, the other side is also a beam. Okay? Mo na makita, duha ka beam ang nakita. Meaning, pag cut ni mo diha, ang naputol is ang kining taas nga beam, ang slab naputol akip o ang lower na beam. So, in which you have picture like this. Nakay picture nga ingon ani. Okay? Kunya, ang tawag ani niya nga span dinhi, usually I will consider only the knit from here to here. Other will use the center to center. So, wala man problema. Both will do. Okay? Kana siya, ang tawag niya is short span. Short span. Okay? So, dinhi dayon, dinhi mo ma-apply ang live load and dead load, no? Part of the dead load, like the weight of the slab. And other nga mga weight ni carry sa slab. Like for example, doon na kay table, doon na kay mga office equipment na naibot lang sa slab, o mga lingkuranan, supa, nadya. So, kini ang slab ang mag-carry. Unya, giatas na siya, gitawag og kaning gitawag og beam. Now, ang beam is much stronger because of its size, no? Like that. Okay? Now, other purpose also of this beam is kung doon na siya mga dagbugat kayo nga mga structure like wall, I will put a wall here. A wall. Palita doon na siya yung mga wall. Dito ni mo na, butangan ni mo na og beam. Para there is a direct structure that will carry the wall. Okay, sometimes wall is heavy, no? Now, kung imo na ibutang sa slab, imagine ang slab nga nipis lang, so uh, ma, ma, makabugatan gid siya, no? Nya, kung imo sa siyang paggaan, pag-ayo ang slab, as I have told you, mubugat pag-ayo imong structure because especially if you are talking about 20 floors, 10 floors, 30 floors, so ang kabaga niya sige lang kag balik-balik, no? So ma-accumulate na siya, so that will contribute to the increase of cost of construction. So this, so if you have wall, you don't put wall here. If in case do na kay wall diha, butangan sa nari mo gitawag og girder nga carry. So that's the other purpose of putting beam here. So I will erase that. Okay. That is only an example. Okay. So, that's it, no? So, muna na siya. So, if that is the case, I will use a symbol, no? I will use a symbol of big load and live load as this, as equal to this. I'll just use symbols, no? I will use symbol. So, I will insert again another figure. Ay, na lang. Yeah, this one. Ano yan, button. So, mo na siya symbol niya, no? Symbol na niya. Ako din na siya i-format ang field niya. Simula ni. Wow. Pattern. Okay lang. Yan na po black. Okay. So, yung anak na dahil siya, no? Muna siya gitawag na live load o big load. Okay. Okay. So, muna siya ang ako na ni-include sa pag-group. So, mana siyang symbol ko sa dead load and live load. Now, ang live load is katong mga tao nga na diha sa floor, usually, makuha ni mo na siya sa code. Na siya sa building code. Kung residential ba siya, doon na siya particular na magnitude. O kung office building ba siya, o gamitin ba siya for whatever. No? So, you just consult the National Structural Code of the Philippines. Okay? And why there is dead load? Of course, doon na may weight ang slab. No? As, doon na pag-ilaing dead load nga kung imong kuan wala dili siya part sa building pero once the building is completed and use it has another big load like for example kana mga office equipment or mga appliances ba no nga ang carry is the slab no okay so those are the weight of the slab okay now we can see that this slab is similar to a beam, no? It is subject to bending, and in fact, the bending is like this, no? When going to draw the bending, it is like this, okay? So this is the bending. This is so insert sheet, insert sheet. Okay. Okay. So akong doing mo ng iyang depicted structure ani, kasi mo na ani, no? Okay, puluan na din ako na red. So, yan na yan depicted structure, no? If you are looking for the tension, there are two tensions there, no? Near the support, the tension is on the upper part, while at the center of the slab, the tension is at the bottom, no? That means that for this particular slab, two sections, there are two sections that you are going to design. One is near the support, and the other one is at the center. Okay. And the shear diagram of this looks like this. No? Oops. Wala ni kuan. Akip sa iya. Look, para okay, pili na siya mo ano. So this is what we call this the shear diagram, assuming that the live load and the dead load are uniformly distributed load, and the next will be the moment diagram based on what we call this approximate way. So we'll first determine the the shear diagram here. The shear diagram like that. Then copy, paste. I will rotate that, flip vertical, and flip. Okay. So this will be your shear diagram. Okay. Okay. So that's the shear diagram, no? Assuming that you have a uniformly distributed load. Yan ang gyapon sa beam, no? So, ang ngalan niya na slab. Okay? So, ang shape sa kuan, sa gitawag nato nga moment diagram, it's like this. Okay? So, I will insert the shape here. Yeah. And then, I will copy that. Then, paste again. Gamay. Ako i-attach diha. Biyahon na ko na siya. Paste na po. Butang ko na din eh. This one. Kunya, butang din ko og cord. Kini siguro. Cord diha. Ay, siya. Insert shape. Kini day. Sabon ko mako og arc. Okay, that's the shape of your moment diagram. Ako lang ni siyang kuan gitawag na oh, good. Mobile one. Skill. Okay. So this is the shape of your moment diagram. Now, since the diagram is simpler, you can use simplistic method of shear and moment diagram. But in general, you can use software. No, you can use software. Uh, just fill up the load and then determine the shear. No, so you will have what we call VU here, VU in terms of like U, no. So meaning factored load na lang to daan imong gamiton dito. Okay. Okay. BU. And here you will have also MU. Naka-MU sa support, naka-MU. Pwede sa buhat yung MU sa midspan. Kaya lahat mo na silang value. No? So, what's yung MU din? So, nagamit ka MU na. No? Either you label this MU2 and then just put that subscript and this one as MU1. Now, the reason why I use MU1 and MU2 is that they are two maximum moment occur at different locations. Okay. So that's how you are going to analyze for one way slab. So next day na ko ani ako ni say. So, ah okay, so that is how you are going to analyze the slab. No? So first I mentioned that the slab is supported by the beams on both sides. Okay. Now there are two kinds of slab, one-way slab and two-way slabs. So let's forget the two-way slab for a while, no? But uh, it should be a part of the structure. But in general, you can analysis of designing one-way slab can be used, no? Uh, because it's safer to design it as a one-way slab. Okay. Now, uh, we usually adapt a rectangular shape system rather than the square system in which they have the short and the long span are equal. So we'd rather have a system in which the spans are different, meaning you have longer and short span. Okay. Now, so let's agree that there is short span and long span. Now, in one-way slab, the direction of the reinforcement is along the short span. Okay, the short span. So in other words, uh, the short span is highlighted. It's highlighted. Okay, that's it. So we are not considering the long span. Now, another question will arise. Sir, what will be the reinforcement along the long span? Nga wala man ka nagyakip sa design. Well, wala na siya gyakip sa design pero doon nagyap ko na siya yung reinforcement. Okay. Ang tawag sa reinforcement niya is dili main reinforcement, kundili temperature bars or temperature reinforcement. Or sometimes they call it crack control reinforcement. Ang crack control reinforcement is it's not designed for strength. Doon na lang na-share mga it's actually code dictated lang ha. Mubalo na lang ka sa code mo gamit kaning ng kadako and then mo na siya iya minimum spacing. Ana, no? Yan. So dili gyud siya iguagi og kanang grabe nga calculation no nga gamit kay moment, determinate mo still ratio ana. No, not like that. So in fact, it's just more of recommendatory but dili sa di mo pabayaan nga dili na nimo putangan og reinforcing bar tanganin mo na siya o gitawag og temperature bars. Sometimes wireless na siya, o sometimes bars na siya. No? So, nangya po yung enforcement ang longer span. Pero, sa one-way slab, only the short span is given uh, attention no? Sa pag-design. Yan, mo din siyang analyzon, i-determine mo ang moment o ang shear. Okay. So, the same as designing a beam, you are going to analyze and then mas maayo sa slab katong investigation type not the tailored type so when mag-determine ka og section and then determine the capacity then after you determine the capacity you compare it with the required capacity kung okay ba siya ligon ba ang slab makakarga ba siya sa demand that's it so after you determine the capacity, you judge whether okay ba or not. And the criteria is, well, again, PMN is greater than NU, so otherwise it's not safe. Then after na mo na determine ang design with respect to flexure, that's the time na determine mo ang yung shear capacity. Okay. Once ma-determine mo ang shear capacity, compare din mo na sa shear. And normally, it is safe. Like that. Then, the third is detailing na rin ka. Imo na dahil doingon ang detail. Kay, dili lang kataman sa competition, kung dili, doingon yun mo keep up detail. Kay, part mo na sa imong bayad. No? So, bayaran na rin ka na sa tag-iya o sa architect nga nagbabuhat sa imong structural. So, ang bayad, depende na po sa imong pagkulit kung pila imong sabot kay you're not going to start to design unless kasabot mo, no? So, like for example, kaan kaniya 200,000, okay? Design na ning building nga bit tagaan ka 200,000. So, what to like after a week mahumaling. So, o niya na human na. Oh, pandaan, bukubulikta dag ka para what? Nice. So, that's how can we make money through designing structures, no? And the more structure you will design, the more what compensation you will get. And this is how this will be our livelihood as an engineer. No, this is only one because uh, designing, but it's not limited only to designing. We can also be a contractor. We can also be a uh, businessman or whatever. So uh, that's it. So what is ano tawag to? So doing mo nimo no. Pero unsa man ang doing kanang drawing mo na ng final nga designing mo para muna na siya ang sundon sa construction, no? Muna na imong tan-awon unya kung mag-inspection ka kung nasunod ba. Niya, in-MM man niya, inyong gigamit gamay kayo, no? 20 mm akong gi specify din ni sa akong competition 20 mm gini niya inyong gigamit kuan substandard 18 mm ra wa abot. So, dili ka gusto nga ipininin kung pwede gali to imo gyud siyang i-reject dili unsaon man na nga nabutang naman na diha so that's the kuan diha ta din kamo kuan unsa gibuhaton para kay ang competition nimo mao mo gyud to siya no nag determine sa safety sa building so you have to decide according to your kuan na tayo conscience no what to do. So, pwede sa imong yun nga, kuan man, gamay man nga bars mong nagamit diha. So, akong gi-compute, kulang ka pa o kuan, tulo ka bars. So, butangin na lang nagtulo ka bars. Okay, okay na kay. At least, ang steel area na meet ya po niya. No? So, you are going to base that on the steel area, not on the diameters. Okay. Eh, pwede man nga, mugamit kag laing diameter, basta ang steel area is still the same. Okay. When you compute for design, as you notice, is the ES. ang come-out sa computation. And then from the is, nangita din kag unsay diameter nga maayo nga dili magbubot ang kabilya dili sa imo gamay kaayo. Kay mogamit kag dagko kung kay nga kabilya, posible nga duha lang kabukang kinahanglan. Mogamit sa kag gamay kaayo pwede sa sobra na pulo, no? So gubot kaayo. So you should be creative also on choosing which diameter you are going to use. Okay. So I will continue with that, no? And at this time, I'm going to design. Okay, to design. Okay, so we'll continue. So we have this. So uh, we will example here. I put an example. This is example. I not know pila pila na ning example. Example. So design the beam in the second floor slab for the structure shown. So ang structure show kung ang structure na paan is kini. Kini ang structure na pinakita. Okay. Ano siya? Uh, for the design the beam in the slab the slab as design a one-way slab, design a one-way slab na lang. Design a one-way slab in the second floor for the structures for the structural plan shown. Structural plan shown. It are used given below. Slide load. Okay. Then I will add another bid load. I will insert row F position A. Button dia paste. Yan kini siya live load, bid load, bid load. Kini lang atong load, no? So, button nato ko siya og 3 kilopascal. Okay. So, slab plus we'll say tile and 3.0. Or let's say 3.6. 3.6. Slab plus tiles. Okay. No other load except live load sa to pahawan ni siya, ni siya open space. Niya pwede siya manahan og tao because you consider the live load. Now the figure will look like this. I will just do this as plan. So ito lang ako i-paste. Aha. Ako is okay. So kini ang akong piyahon. Copy. So ano siya? One way slab. So sa plan mo ng labas. So let us say ang long span is 6 meters. Yeah, ang short span is 3 meters. 3 meters. Okay? 3 meters. So, pangalan nato ni siya section A. Copy paste. So, imong section karon is imong for example. Okay. Yan yung section. section. Okay, for the section A. So, tawag na ko na siya ang label A. Okay, so this is the section A. Section A. Section A, elevation value niya. So, I will just copy this one. Copy and paste. Put it there. So, mauna ni siya. Like that. So, muna ka na yung section A. But we are going to compute with the WU. WU. WU natin ganito, which is 1.2 dead load plus 1.6 live load. Okay. Now, WU. Now, the question here, how do we compute for the dead load and live load? The given is in kilopascal. Look, this is in kilopascal given. Okay, kilopascal. So, this is very tricky, ha? This is tricky, no? This is how we do it, no? So, ang gibuhatan niya is gamit ka og using 1 meter strip of slab. Using 1 meter strip of slab. So, meaning that the you use this one. Only 1 meter strip. That one. I will uh, uh, pattern to be push huts. Where's the push huts here? I just okay. So I just use 1 meter. 1 meter. I'm not going to use the 1 meter, but rather the 1 meter strip. 1 meter strip. So so just use lang 1 meter strip, no? Not the whole. So if you are going to use 1 meter, in order to convert the 1.9 kilopascal and 3.6 kilopascal, so your dead load will become 1.0 times 3.6. So instead, nahimon 1 meter, 1 meter, 1 meter times 3.6 kilopascal, and the result will be 3.6 kilonewton per meter. The same as you will do also for your live load. Your live load will become uh, 1.0 meter, ganun 1 meter man sir, because mo na imong basis, no? EPE. EPE equals to 1.9. Instead na EPE, hindi mo na kilonewton meter. Okay? So, that means na kung sa gali ang reinforcement nga imong na-design dani, you are going to repeat that to the adjacent strips further. So, i-repeat lang nimo, no? You consider 1 meter strip so that you can have your shear and moment for this particular strip, and whatever reinforcing bars that you will come up will be adapted to the immediate sides. So per meter again, no? So that's the idea. So when you compute, when you calculate for WU,